Okay, so recursion. Recursion, solving a problem by breaking it down by solving the same problem on a smaller part of it. So we looked at the Fibonacci sequence, and the Fibonacci sequence of n is whatever the Fibonacci sequence of n minus 1 and n minus 2 are added together. So you can just do that by calling the same function. Okay, so if we have a look at a string of characters, let's say ABC. What we're looking at today is permutations. So how many different permutations of ABC can we get? Well, we got ABC, ACB, BAC, BCA, CAB, and CBA. Okay, that's all the permutations of those letters. Now let's say we want to get all the permutations of ABCD. We could go through and process one at a time, and yeah, that will take quite a while to do. We could have a look at each one of these and say, okay, well, if those are all the permutations of A, B, and C, all I need to do is for each permutation and then a D to every place. So you can solve the problem of that, of ABCD, by solving the problem of ABC. So what we're going to do is try and make a program that will find the permutations of a word. So we will call it result is permutation of, we'll just start with ABC, and that should print a list of all of these. Now when you're writing this program, you need to be thinking of two different cases. The base case, so what is the most simple case? So any answers on Teams? What's the most simple case of getting all the permutations of some letters? So what's the simplest version of this program, of this problem, which you could be presented with? Spot on. One letter. Yeah, could be none as well. I think one letter is sufficiently simple. Okay, so what you'll need to do is do a check to see if it's the base case, so if it's only one letter, and then return that one letter sorted. And then you need the general case. So how do you solve it for n? So if we've got that, if we've already solved it for C, then what are we doing with B to make sure that that's every single combination? The way which I was working it when I tried to solve it was, okay, if we take each letter, can we chuck that on to each of the permutations of everything else? can we take the B, put it onto every permutation of everything else? So I take A, add onto permutations of BC. So that would give us BC and CB, and just chuck A onto that. Then the next letter is B. Of AC. So extracting that one letter and doing everything else. And then the permutations of AC are AC and CA, then we're just putting a B on the beginning. And so you can see that we're solving it for every single one, just by going through each letter and finding all the permutations of everything else. So hopefully that gives you a starting point. A quick hint, if we have a string of that, let's say we want to get the character in position 2. Okay, that's C. How do we get everything before 2? Well, you can go 0 to 2, and that will get AB. Okay, how do we get everything after C? Well, if we did that, it will get C and upwards, but we don't want C itself, so that. So test 0 to 2 plus test 2 plus 1 to the end will get you everything except for that letter. There's a hint for you. Okay, so have a go at trying to solve this recursively, and funnily enough, in here somewhere you will have to be calling the function itself. Hopefully that work through will give you an idea of how to approach the problem. Give it a go.